Hello student, this is the third video on set theory. In this video, we will learn about the operations on set. So first one is union or joining of sets. The union of two sets A and B is the set of those elements which are either in A or in B or in both A and B. So we can write A union B in the set builder form X such that X belongs to A, V X belongs to B. This V is the symbol of OR learned in the previous video. In simple words, it can be said that each element denoted by X that belongs to A union B implies that they are the element of either A or B. Now take some examples. Let the universal set denoted by U is the set of natural number up to 8 and A is the set of positive even integers less than 9, those are 2, 4, 6, 8, and B equals 1, 2, 3, 4, 5 in the tabular form. Then the union of these two sets is 1, 2, 3, 4, 5, 6, 8. So what are we doing in union is listing all the elements of A and B together in tabular form. We can see that every element of A as well as every element of B are the member of A union B. And also note that in this example 2 and 4 both are the common elements of set A and B. So when joining these two sets, don't write 2 and 4 two times as a set has all the elements distinct. Let's see how to draw a Venn diagram of A union B. In Venn diagram, the universal set is represented by a rectangular region and its subset by circles inside the rectangle. The set A is represented by the left circle and set B is represented by the right circle. These two circles are intersecting as they have common elements. Now write the elements of A and B inside the circle respectively. Then A union B is represented by the whole intersecting circle region. Now take another example. Let A be the set of all real number greater than or equal to 3 and less than 7. It can be denoted by the interval form also. And B is the set of all real number greater than 5 and less than or equal to 10. As these two sets are non-denumerable infinite set, we can't represent these in tabular form. To find out the union of A and B in a simple way, let's draw a number line and mark 5 points 0, 3, 5, 7 and 10. Now to indicate set A and B, we draw a red line from 3 to 7 and a green line from 5 to 10 respectively, where 3 and 10 are included and 5 and 7 are excluded. Then shade 3 to 7 region with red and 5 to 10 region with green. So union of A and B is the whole shaded region in the number line, that is all real number between 3 and 10 both are included. So the next topic is representation of union of 2 and 3 sets in Venn diagram. First draw two rectangle region to represent universal set and two intersecting circle inside them. Then shade one of them with orange and another with green lines, which represent the set A and set B respectively. Therefore, A union B is the region covered with all the lines and shade the whole part with red lines. Similarly, to represent the union of three sets, we draw three intersecting circles inside the rectangle and shade them with different colored lines. Then the union is the whole colored part shown in the bottom right rectangle. Some properties of union are A union A equals A. It's called idempotent law. The second one is A union universal set equals universal set. Third, A union null set equals A. Fourth and fifth are A and B both are the subset of A union B. And the sixth one is A union B equals B union A. It's called commutative law. And the last one is associative law, and we can write it as A union B union C. Now if we have some sets like A1, A2, A3 up to An, then the union of these sets written as intersection, another operation on set, is the set of all elements which are common in both A and B. In the set builder form, A intersection B equals x such that x belongs to A inverted V, which is the symbol of AND x belongs to B, which means x is a element of both A and B. Now from the previously given example, A intersection B is the set of two elements 2 and 4, as 2 and 4 are common elements in both A and B. Another example on interval, the intersection of these two sets is the common part on the number line, that is the real number between 5 and 7 where both are excluded, can be written in the open interval 5, 7. Representation of A intersection V in Venn diagram is similar to A union B. First draw green lines to represent set A and orange lines to represent set B. The intersection of A and B is the region where all lines are intersecting. Same thing goes to represent intersection of three sets. The properties of intersection are also similar to union, except the second, third and fourth. Second one is intersection of any set and the universal set is the set itself. Third one is intersection of A and null set is null set also, as they have nothing in common. Fourth and 5 are A intersection B is the subset of A as well as B. If we have n different sets named A1, A2, etc., then the intersection of these all sets written as. Next one is disjoint set. If two sets have no elements in common, then intersection of these two sets is null set and they are called disjoint set. In Venn diagram, the circles will not intersect or touch if they are disjoint. In real number system, the set of rational and the set of irrational number are disjoint set. Next operation on set is difference, denoted by A minus B or A slash B. It is the set of all elements that belongs to A but not a member of B, written in set builder form x such that x belongs to A and x doesn't belongs to B. Again from the previously given example, A minus B is the set containing 6 and 8 only. Though 2 and 4 are the elements of A, we select 6 and 8 only in A minus B, as 2 and 4 are the elements of B. Similarly, we can write B minus A equals 1, 3 and 5. In the other example of intervals, A minus B is the closed interval from 3 to 5 and B minus A is also a closed from 7 to 10. Venn diagram of A minus B is represented by the green lines only, not the part of intersecting lines, and B minus A is represented by the red lines only. In the top right rectangle, we can see that the green part is A intersection B, the blue part is B minus A, and the red part is A minus B, and they are all separated, not intersecting to each other. The properties of difference are A minus B is a subset of A and B minus A is a subset of B. Third one is A minus B, A intersection B and B minus A are disjoint set as shown in the Venn diagram. Fourth is union of A minus B, A intersection B and B minus A is A union B. Next, A minus B can be written as A union B minus B or A minus A intersection B also. If we take a set A equals 1, 2, 3, 4 and be a set containing the elements 3, 4, 5, 6, then A union B is 1, 2, 3, 4, 5, 6, where A intersection B is 3, 4 and A minus B is 1, 2. See, if we eliminate the elements of B, that is 3, 4, 5 and 6 from A union B, we get A minus B. And similarly, if we eliminate the elements of A from A union B, we will get B minus A, that is 5, 6. We color the A minus B green and B minus A yellow and A intersection B orange. The sixth property is B minus A equals A union B minus A or B minus A intersection B. Seventh property, if A is a proper subset of B, then A minus B is a null set. The last one is, if A and B are disjoint, then A minus B equals A itself. The operation of symmetric difference of two sets is the union of A minus B and B minus A. It is denoted by A delta B, where delta is a Greek alphabet. We represent the Venn diagram of A delta B by shading the circles with red. Complement of a set is denoted by A dash or A to the power C, is defined as U minus A, is a set of all elements of universal set except the element of A. We can see the Venn diagram, the green part represents the set A, whereas the yellow part represents A complement. For example, if we choose a universal set containing the natural numbers up to 6 and a set denoted by caps A containing 2, 4 and 6, then A complement will be the set of 1, 3 and 5. Now, the properties of complement is the complement of a set is the set itself. That means A complement, then complement equals to A. Complement of a universal set is null. Complement of a null set is universal set. Then the union of A and A complement is universal set, and intersection of A and A complement is null set. Now I am presenting you some important laws and properties of set and Venn diagram of sets also.